Section 3.4 Optimum values of quadratic functions. The word optimum means maximum or minimum. So we want to find the maximum or minimum value of a quadratic function. But then this time we don't want to plot the graph like what we have done. So let's see how we do it. So first of all, let's look at the original graph. Now here I have original graph y equals x squared. And if I add 3 to y, that means the graph will be moved upwards by 3 units. Similarly, if I have the original graph y equals x squared, but this time I take y equals x squared minus 3. If I minus 3 to the value of y, the original graph will be moved downwards by 3 units. So in general, if we move the graph y equals f of x upwards by k units, then we get the graph y equals f of x plus k. And if we move the graph y equals f of x downwards by k units, we get the graph of y equals f of x minus k. So moving the graph up or down will change the y values. So that's why we add k or minus k outside. So that would have we will affect the values of y. So you can refer to these two figures. This one is moving the original graph upwards by k units. This one is moving it downwards by k units. After looking at moving the graph up or down, we are going to see how to move the graph left or right. So first of all, let's take a look at the original graph. So I have my original graph y equals x squared, and if I add 3 inside the bracket, this would have an effect on my x value. So the original graph will be moved to, you can guess, it seems like we are moving it to the right because x plus 3, but in fact we are moving the original graph to the left by 3 units. Similarly, I have the original graph y equals x squared, and if I minus 3 inside the bracket, this would change the x value, and my original graph will be moved to the right by 3 units. So you might want to know why this will be the case. So after moving the graph to the right by 3 units, my vertex becomes 3, 0. Note that I'm maintaining the same value of y, but x increased by 3. So in this case, for my new graph, when x equals 3, y equals 0. So you can see that x has actually increased by 3. So in order to compensate, that's why inside the bracket I have x minus 3, because the value of x has increased. So that's why in my function I have to subtract by 3. So I hope you understand this concept. So let's go back to your notes. So in general, if we move the graph to the left by k units, then we get the graph of y equals f of x plus k. And if we move the graph to the right by k units, we get the graph of y equals f of x minus k. For the time being, we have seen how to move the graph up or down, that's translation, upwards, downwards, or the other one is left or right. So we have moving the graph leftwards or rightwards. Note that the shape and the size of the graphs do not change. So the original graph has the same size and shape as the transformed graph. Last time we have looked at some features of quadratic functions. One of the features is the vertex. So if the quadratic function is in the form y equals a times x minus h all squared plus k, I can make use of x minus h to find the vertex. So this is how we find the vertex, which is located at hk. And since the graph is opening upwards, I know there should be a minimum value of y. And it happens that the minimum value of y equals k in this case. We can also identify the axis of symmetry, which is located at x equals h. So if the graph is opening outwards, we get a minimum value of y. On the right, we have the graph that's opening downwards. Similarly, I can find the vertex. So the vertex is located at hk. And since the graph is opening downwards, I get a maximum value of y, which is k. I can also find the axis of symmetry, which happens to pass through the vertex. So the axis of symmetry is x equals h. So let's look at one example to see how we can find the maximum or minimum value as well as the vertex and the axis of symmetry. Example 3.14. For each of the following quadratic functions, find its max or mean value. Part 2. Coordinates of vertex and axis of symmetry of its graph. So first of all, we have to know whether the graph is opening outwards or downwards. So we look at the coefficient of x squared. The graph opens outwards, we get our minimum value. So the minimum value is -5. So we have got part 1. Part 2, coordinates of the vertex. Vertex is located at -2, -5. So you can make use of x plus 2 equals 0 to get the x coordinate of the vertex. Or you can skip this if you want. You can just write down the vertex directly. You can also put down the axis of symmetry. Which is x equals -2. Note that if you write axis of symmetry equals -2, this is wrong because you just put down the value. It's not the axis of symmetry. So the axis of symmetry is our vertical straight line. So let's move on to part B. First of all, I have to rewrite my quadratic function in the form of y equals a times x minus h all squared plus k. Not done yet. So I want to make sure I don't have 2x minus 5 inside the bracket. So I have to take out 2 first. So I have -2 times 2 squared times x minus 5 over 2 squared plus 1. So that would give us -8 times x minus 5 over 2 squared plus 1. And we are ready to find the max mean value of y. So after all this, then you can see I have rewritten my quadratic function in this form. So let's do part 1. So here we are going to look at the coefficient of x squared, which is -8, which is less than 0. So the graph opens downwards. And that means I have maximum value of y. So the maximum value is 1 from here. I can also put down the vertex. So part 2, the vertex would be 5 over 2, 1. And the axis of symmetry is x equals 5 over 2. If you want more information on how to find the vertex, then you take x minus 5 over 2 from inside the bracket, set it equal to 0, so you get x equals 5 over 2. So we get the x coordinate of the vertex. The y coordinate of the vertex is actually the maximum value of y. So after looking at these 2 examples, You can try quick practice 3.14, further practice, as well as extra practice on your notes page 15.